Good evening, students. Up till now, we have discussed about oxidation number, charge, and valency. In my previous 4 videos, I discussed not only exceptional elements showing exceptional oxidation numbers. In this 5th and last class, I will be discussing some more compounds and the oxidation state of the constituent elements there in such compounds. See, there is one more very important compound, that important compound is CrO5. CrO5. CrO5, that is chromium 6 oxide. Chromium 6 oxide, it is having butterfly structure. It is having butterfly structure. How it is? This is Cr, this is peroxide, peroxide, this is also peroxide, this is peroxide, and this is oxide. So its structure is like this. That's like as peroxide, that's like as butterfly. This oxygen will be -1 because peroxide. This oxygen will also be -1 because peroxide. O linkage, that's called peroxide linkage. So in peroxide, oxygen will always be -1 charged. In oxide, oxygen will be 2- charged. In peroxide, oxygen will be -1 charged, and in superoxide, oxygen will be -½ charged. So oxide, peroxide, and superoxide. So this oxygen is also peroxide linkage showing. So oxidation number will be -1. This oxygen will also be showing peroxide linkage. So we'll be having -1 oxidation state. What about this oxygen? This oxygen is normal oxide. So we'll be having -2 oxidation state. So -1, -1, -1, -1, that is -1 into 4, then plus. This oxygen is -2 and 1 in number. So this will be -6 and this Cr will be +6. So -6 plus X is equal to 0. So X will be equal to 6. That's why you wrote here that chromium 6 oxide. So this is chromium 6 oxide. How else you can write this CrO5? You can write it like this too. CrOO2 whole twice. These are 4 oxygen atom, 4 peroxide oxygen atom ions, and this is oxide ion. So -4 in plus -2, that will be -6. So Cr will be 6 plus. So this is CrO5, that is chromium 6 oxide. Now what next is? Next is bleaching powder, CaOCl2. What oxidation state Cl here is showing there in this bleaching powder? See, what does it means? It means CaOCl plus Cl. This Cl is minus charged. This Cl is minus charged. And what about this Cl? Here, O and Cl. This Ca is 2 plus charge now. So 1 minus here, then this will also be having 1 minus charge OCl. How it comes? O is more electronegative than Cl, so we'll be showing -2, and this Cl will be showing +1. So -2 plus 1 will be -1. So 1 Cl is showing here in this bleaching powder 1 plus oxidation state, and another Cl is showing 1 minus. This Cl is 1 minus, and this OCl, oxychloride, is 1 plus. That Cl is 1 plus charged. So it is this oxychloride, that is hypochloride. That hypochloride, OCl minus is hypochloride. This hypochloride, in this hypochloride, this is hypochloride. In this hypochloride, Cl is 1 minus, Cl is 1 plus charged, and in this chloride, Cl is 1 minus charged. Now one more exception is there, that is hydrozoic acid, N3H. N3H, hydrozoic acid. In this hydrozoic acid, N3 minus, that is azide ion. N3 minus, that is azide ion. In this N3H, this is N3H. This nitrogen is trivalent, this nitrogen is also trivalent, and this nitrogen is pentavalent. Fine. Now see, this nitrogen, because of this will be having zero charge, zero oxidation number. This nitrogen will also be having zero oxidation number because it is further attached with an atom. As in my first class itself there on this topic, I already told you that OO linkage, in that OO linkage, O is 1 minus charge, otherwise in rest of the CC, PP, NN, BR, in all these linkages, elements are SS, elements are zero charged. So here this NN linkage, so because of this nitrogen, this will be having zero charge. This nitrogen, because of these two nitrogens, will be having zero charge. What about this nitrogen? This nitrogen, because of this nitrogen, will be having zero charge, and because of this H, will be having 1 minus charge. So this H will be 1 plus charge. That is what I told you, that N3 minus. So one nitrogen will be having, one nitrogen will be having 0, and second nitrogen will be having -1 oxidation state or charge. So this is about hydrozoic acid. Now see next compound, Fe.94O. In this, what oxidation state this Fe is showing? So 0.94x minus 2 is equal to 0. So 0.94x is equal to 2. So x is equal to 2 upon 0.94. If we'll remove this decimal, then this will become 200 upon 94. So what is the oxidation state of Fe in Fe.94O? That is 200 upon 94. So this is fourth example for this oxidation number. Now see, we'll discuss the fifth example too, Ki3. What Ki3 is? Potassium superiodide. In this potassium superiodide, what oxidation state iodine is showing? In this Ki3, this is I3 minus. Ki3 means I3 minus, that is superiodide ion. So it will be having linear structure. It is in this this iodine will be showing 0. This iodine will also be showing 0 oxidation state, and then this oxygen, because of this iodine will be having 0, and because of this K, it will be having 1 minus. So this will be -1 charge. So here the oxidation state of iodine in Ki3 is 0 and -1. Fine. What hybridization here related to this I3 minus? There is one more important thing, that is about hybridization. See, it is having trigonal bipyramidal geometry as well as linear geometry. In this trigonal bipyramidal geometry, it will be showing sp3 dehybridization, and bond angle will be 120 degree and 90 degree, as we have done this all there in class 11th. And what about this one? Shape will be trigonal bipyramidal. Shape will be trigonal bipyramidal. And it can be linear also. When it is linear, then hybridization will be sp, bond angle will be 180 degree, shape will be linear. This is according to NMR. Nuclear magnetic resonance technique, which gives about the average structure of the molecule. Here only bond pairs will be considered, that's why hybridization will be sp. And here bond pair plus lone pair both will be considered, that's why hybridization will be sp3d, shape will be trigonal bipyramidal, and bond angle will be 120 degree and 90 degree. What this technique is, this was non-nuclear magnetic resonance, and that's the average structure that gives you an idea about the average structure. And what this technique is, this is electron diffraction technique, and this electron diffraction technique gives you exact structure of the molecule, because there we will be considering bond pair plus lone pair both. So that is why it is a modern technique, and NMR is classical one. So this was about Ki3. In hybridization, obviously in chemical bonding, you will be talking about this hybridization also, but here just I have given a brief idea about the hybridization shown by Ki3, and was there in examination also. So this is molecular geometry, this is molecular geometry, and this is electron pair geometry. This is electron pair geometry, and this is molecular geometry. Now we will see some more exceptional compounds too. See one more, C3O2, that is carbon suboxide. C3O2, carbon suboxide. You know about carbon dioxide, carbon monoxide, but C3O2 is carbon suboxide. This carbon, because of this oxygen, will be having +2 charge, and because of this carbon will be having 0. So net charge it will be having +2. What about this carbon? This carbon also, because of this carbon, will be having 0, and because of this oxygen, which is -2 charge, this will be having +2 charge. What about this carbon? Because of this carbon and because of this both carbons, this will be having 0. So in C3O2, carbon is showing +2 and 0 oxidation states. What about Br3O8? Br3O8. See here in this Br3O8, this Br, because of this Br will be having 0 charge, and this is -2, this is also -2, so this will be having 4+. This Br, because of this Br will be having 0, and because of these 3 oxygen atoms will be having 6+ charge. This Br will be having 6+, this Br will also be having same 6+. So here in this Br3O8, Br is showing 6+ and 4+ oxidation state or charge. So this is all about a few exceptional oxidation number of important compounds from where they can ask you questions. In brown ring, Fe is 1+ charged, Fe is 2+ charged, but in Fe complexes, if NO is there, then that NO will always be 1+ charged, and that NO will be giving its 1 electron to Fe2+. So this Fe2+ will take electron from NO, and this Fe2+ will get converted into Fe1+. And is this Fe1+, its configuration will be 4s0 and 3d7. This Fe will be 4s0, 3d7. So 3 unpaired electrons. So its magnetic moment will be 3.8 bm approximately. 3.8 bm approximately. So this is all about the oxidation number. Fine. Thank you very much you all for watching my video. This topic, oxidation number, charge and valency, is over, and we expect questions from these topics only, these examples only. They are in IIT JEE or NEET. Let's see. All the very best. Thank you.